Good afternoon and welcome to today's OR Today webinar, an ultrasonic cleaner's role in preventing dirty surgical instruments. Today we are joined by Kevin Anderson, Clinical Education Specialist at Healthmark Industries. OR Today would like to thank our sponsor, Healthmark Industries. Since 1969, Healthmark Industries has developed and marketed innovative solutions to aid healthcare facilities in their delivery of surgical instruments and other life-saving medical devices to patients. Healthmark Industries' mission is to continue to innovate, support and serve the healthcare provider industry and support services that make it possible to deliver quality healthcare. Please visit hmark.com for more information. Just a quick reminder that if you missed any of our past OR Today webinars, you're still able to view them on our website, so please visit ortodaywebinars.live. Today's webinar is eligible for one continuing education hour from the California Board of Registered Nurses, and you can obtain your certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1C certificate, and you'll be able to download the certificate directly from your computer once the survey is submitted. This webinar is also eligible for one contact hour from the CBSPD, and you'll be able to scan a QR code that will appear at the end of Kevin's presentation. If you have any questions, you can reach us at webinar@mdpublishing.com. Okay, let's kick off today's webinar by giving away one of our fabulous OR Today live lunch bags to the attendee that can tell me the answer to the following trivia question. October is National Pizza Month. What is the most popular pizza topping? Answer now using the questions feature on your dashboard, and I'll reveal the answer at the end of the webinar. We'll have a live Q&A at the end of today's presentation, so please submit your questions anytime using the questions feature on your webinar dashboard. As I mentioned earlier, our presenter today is Kevin Anderson. So Kevin, you may begin whenever you're ready.
All right, thank you, Linda. I'm just gonna turn my camera on real quick, and then we will get going here. So we're gonna get into this presentation. It's called An Ultrasonic's Role in Preventing Dirty Surgical Instruments. Now, normally we would run a poll question to see who's kind of in attendance here, and so going based off historical attendees, I'm gonna assume that some of you out there are operating room staff, OR nurses, surgical techs. Some of you might be infection preventionists, and then there's going to be a nice contingent of sterile processing folks out there. So my hope is to make this kind of applicable to any of you guys out there. And for those of you who work in the operating room, I just want to thank you for taking the time to learn a little bit more about sterile processing. I think there's a huge knowledge gap there that really, it's easy to think that it doesn't matter in our role in the operating room, but I do think that it does, especially with how much we rely on sterile processing to provide us clean and sterile instruments, as well as to provide service in a time-efficient manner, in a reliable manner. So with that being said, let's go ahead and get into this. We have some objectives, as always. We're going to review the various functions of ultrasonic cleaners used for cleaning reusable medical devices. We're going to look at what ANSI AMI ST79 says about testing and verification of your ultrasonic cleaner. And then we're going to talk about some action steps on how to verify that your ultrasonic cleaner is effectively removing soils, specifically from lumen instruments. And that's kind of a very a narrow focus, and there's a reason for that you'll discover as we go through this. So why does this topic matter? Well, hopefully it's pretty obvious to you, but in case you haven't noticed, there are increasing numbers of headlines coming out where hospitals or patients are being affected by dirty surgical instruments. In some cases, it's leading to lawsuits like the one that you see here on the screen. And unfortunately, if those of us who work in the operating room or sterile processing, hopefully you can kind of reflect on your own facility and realize that this isn't something that just happens out there in the world somewhere. This will never happen to us. If you're completely honest, this kind of thing could almost happen anywhere. We've all had to at some point open up a sterile field, and unfortunately, as we get ready for the case, we run into a dirty instrument or what have you. Something is wrong, and we have to restart the whole thing all over again. Hopefully, it's not in the middle of the case, but that is something that also can happen as well. And that being said, it's going to be really important that all of the equipment, whether it's in the operating room or in sterile processing, is working properly. Because just like any time in healthcare, it feels like the resources are low, our instruments are more complex, and surgery depends on sterile processing for revenue and patient outcomes. So it's very important that all of our automated equipment is actually functioning properly. So, which brings me to this slide where on the left we have a washer disinfector, and on the right we have just a common standard ultrasonic cleaner. Now, these are two of the probably the most common automated cleaning equipment that you will find in a sterile processing department. Some smaller facilities like ambulatory centers may or may not have this equipment, but for those of us that do have this, automated equipment can be a real lifesaver when it comes to efficiency and quality. The problem is just like any other piece of equipment, things can go wrong over time. Just like your car needs preventive maintenance, your ultrasonic cleaner needs preventive maintenance. And just like your car may need to be diagnostically tested every once in a while, these kinds of things, ultrasonic cleaners, washers, they need to be tested as well. So we can make sure and have, some level of assurance that it's working properly. So that's going to bring us to our objective number one. We're going to review the various functions of the ultrasonic cleaner, because this is something that, if you've never heard me talk about this in the past, it just helps me to understand the equipment better when I break it down into the various functions that it performs. And it could be something unique to an ultrasonic cleaner or a washer disinfector. They have different functions now, and as time goes on and innovations take place, some of those functions change or evolve. So that's just something that helps me kind of break it down and understand it, and so that's how I like to present the information. So getting into basic function number one, an ultrasonic machine, a cleaner, the thing that sets it apart and actually makes it an ultrasonic machine is that it produces cavitation. It works by way of cavitations, and cavitation is what we would refer to as the mechanical action of the ultrasonic. So when I talk about mechanical action, if we were talking about manual cleaning, that mechanical action is what takes place when you apply the brush to an instrument and you scrub back and forth and cause friction and all of that. That is the mechanical action. In a washer disinfector, the mechanical action comes from the impingement of the water, which is basically how the water knocks off any soils, basically by virtue of the water pressure itself. So impingement is the mechanical action in an automated washer. The ultrasonic cleaner is unique in that the mechanical action comes from cavitation, and that cavitation produces microscopic bubbles within the tank of water that implode violently, creating this mechanical scrubbing action. And what's great about it is based on, the frequencies, whether it's high frequency, low frequency, or alternating frequencies, those bubbles can be smaller or larger and kind of get into all the little cracks and crevices that are, very common with surgical instruments. Now, key components of producing that cavitation function are ultrasonic generators, like you see here in the middle of the screen. All right, that's just an example of one generator. There are many different looks of the generators, but it's a good idea in your department to get an understanding of the ultrasonic cleaner that you have. Where's the generator? Does it have an on-off switch? That kind of thing. And then the generator feeds the energy to the transducers, is what you see on the right side of the screen. Now, these are external transducers. Sometimes they have transducers that are on the inside of the tank, but these ones are on the outside, and these are probably the most common that you'll see. But sometimes those transducers can break or fall off of the tank, and so you could have a problem with cavitation if that happens. So these are some, areas to look at if you have an issue with cavitation. Sometimes the generator is turned off. You see that on off switch. Sometimes it's just turned off because someone was doing maintenance and they turned it off while they were doing maintenance, forgot to turn it back on, whatever. It does happen, but that is the basic understanding that I try to share with people about cavitation. All right, so what does it look like? It kind of looks like this. I feel like it's a good idea to share a little bit about, what does cavitation look like to the eyes? So many times in ultrasonic cleaner, in sterile processing, the real world, we have to have the lid down. It's an automated lid. We don't get to actually see what's going on. So this is actually a video, but the video isn't going to work, and that's okay, because basically all I'm trying to show you is all these rippling effects that are taking place in the water. And that's just to show you that, hey, there is a visual cue there that indicates, yeah, there's cavitation taking place. The ultrasonic is doing something. All right. So it is just a visual representation of what's happening under the water there. And it's just, I feel, an interesting thing to learn and understand about it, because there are some situations where out there where you might have a small tabletop sonic that you actually have to put the lid on and all of that. So just an idea that I thought I would share, because I thought it was interesting when I finally actually got to see an ultrasonic while it was operating. All right, so basic function number 2. So the other thing that is really important about ultrasonic cleaners is that it actually removes surgical soils. This is common. So these functions, function number 1 and function number 2, are common with all ultrasonic cleaners, and that goes for any medical device ultrasonic cleaners in sterile processing, or in the automotive industry, they clean auto parts with ultrasonic cleaners, or in jewelry, they clean jewelry with ultrasonic cleaners. It's got to remove soil and it's got to produce cavitation, and both of those things kind of go hand in hand. All right. Um, Obviously, that's one of the big ones with ultrasonic cleaners and sterile processing. Now, the reason I separate these two out, because you might be asking yourself, well, doesn't it take cavitation in order to remove surgical soils? Well, and in a sense, yes, it does, but you could still remove some surgical soils without the presence of cavitation, just by virtue of soaking the instrument. So it's really important to understand that, in my opinion, that there are two different distinct functions there, and that we want them both to be working. Which then leads me to this screen, which, to kind of further break it down, if you are trying to remove soil with this basic function number 2, I call it, cleaning, removing soil, you have to have several factors working properly in order to do it the right way. And that would be cavitation has to be present, but there should be detergent. And because you have detergent in there, you should have the right temperature in accordance with the detergent IFU. And then you're going to need the right exposure time. All right. There's times now where I go around and into hospitals, and I still sometimes see an ultrasonic cleaner set to a cycle time of like 5 minutes. Well, a lot of times in today's sterile processing world, with how complex our surgical instruments are, 5 minutes just isn't long enough to really get that cleaning function adequate. All right. And in fact, a lot of IFUs that I've looked at, whether it's orthopedic instruments or robotic, a lot of times they even specify up to 15, 20 minutes for a standard ultrasonic cycle. So if you're still using 5-minute ultrasonic cycles, I just encourage you to go back, look at the IFUs of the instruments you're cleaning, and also to be running tests on them to make sure that they're actually performing this function adequately. All right, so now we're going to get into that function number 3, which is soil removal from lumened items. So as you know, in surgery, we have a lot of cannulated or lumened items now. In fact, it ranges from simple suctions or needles, reusable needles, to flexible reamers, to robotics and laparoscopic instruments. So there's a lot of complex lumened items now. And for the soil removal to take place well within lumens, you need the right water pressure, you need the detergent still, you need the right water temperature, again, in accordance with the detergent. And you need patent tubing and connectors and also the filters. So there's a different set of equipment sometimes in these ultrasonic cleaners where they're actually equipped to flush and clean these internal channels and lumens. So we need all these factors to work properly in order to get the adequate soil removal from these internal lumens. So that's kind of that third basic function. I will say, just as a general thing to be aware of, I'm seeing another function being added to some ultrasonic cleaners now, which would be thermal disinfection. Thermal disinfection is just a low-level disinfecting cycle with hot water, all right? But if your ultrasonic cleaner is equipped with that, then you have to understand that, one, your cycle times will probably be a little bit longer, and number two, there's probably an onboard heating element in the ultrasonic cleaner that could also fail. So you would want to test your water temperature to make sure that it actually reaches that thermal disinfection level. So that's just something to be aware of. That is kind of something that I'm seeing more and more of. But for the purposes of this specific presentation, I wanted to dig in more with this function number 3, this soil removal from within lumens. And as we go, you'll kind of understand more why I wanted to dig into this one specifically. And starting with this, okay, so what you see here is an abstract of a study that was done by Dr. Alpha. I don't expect you to read the entire study. I'm going to kind of give you the overall theme of it. Of course, you are welcome to go and read the whole thing, and I definitely encourage you to. But the highlights of this is that she was comparing manual cleaning versus automated cleaning. And these are the takeaways, all right? Manual cleaning left 2 to 50-fold more soil residuals, okay? That's quite a bit different from the automated cleaning, where that achieved 99% reduction in soil parameters. All right, so hopefully what this is meant to illustrate to you is that automated methods for cleaning are generally much more effective and much more reliable, provided they're working properly. All right, so in those places, I've been to ASCs, I've even been to hospitals now where sometimes they don't even have an ultrasonic cleaner. You're missing out on a lot of potential efficient cleaning equipment and effectiveness if you don't have this equipment, or if you're not using it the way it was intended. So a little bit more about this soil removal from lumens. It's good to know a little bit about the anatomy of your unique ultrasonic unit. Now, this is just one that we commonly see out there, but there are many different makes and models of ultrasonic cleaners. But as you can see, it looks kind of complex, all right? And so what we need to do is kind of learn some basics like you would, when you operate your motor vehicle. Hopefully you know what the engine looks like. Hopefully you know where the oil goes. Hopefully you know where the windshield wiper fluid goes, that kind of stuff, right? It's a good idea to understand some of those basic things with your cleaning equipment as well. So that's what I'm trying to illustrate here for you. So I show you here, there's a detergent pump. So understand that this detergent pump, what's unique here is that the detergent pump, there's only one of them, and it feeds both sides of the ultrasonic unit. So you can see here, this is a double-sided, I would refer to it as a double-sided or dual basin ultrasonic unit, and it has one pump that sends detergent to both sides, okay? That's not, I'm agnostic to whether or not that is good or bad. It's just something to understand. And then we have over here, there's pump number 1 and pump number 2. So in this circumstance, so we're talking about soil removal from within lumens. This uh, particular sonic can hook up a lot of lumen instruments and flush them out and clean them out. And it actually, in this case, uses 2 different pumps. One pump is for the left side and one pump is for the right side. All right. So understanding, if you had any trouble with a lumen cleaning function in this sonic, it may be one pump and the other pump is fine, right? So that's kind of where I'm going with this is um, understanding some of those basics will help you understand how to troubleshoot if you ever run into a problem. And yes, I know biomed or clinical engineering or your service rep will probably get involved if something like this was wrong, there's something wrong. But at least if we have a basic understanding, we might understand what we need to tell them before they even show up, right? Because so much of the time we put in a work order to have something repaired and it's down for a week or 2 or whatever because the sales rep had to come in, they had to diagnose, then they had to order a part, then they had to wait for it to come in and all of that stuff. Maybe we can help expedite that whole process if we know a little bit about what's going on and where to direct them when they come in to repair it. So we're going to get into objective 2 now. Hopefully that rounds out your basic understanding of what I call the 3 basic functions of an ultrasonic cleaner, at least with the medical devices anyway. But objective 2, we're going to review recommendations from ANSI AMI ST79 for the testing and verification of ultrasonic cleaners. All right. If we want to know what we should be doing every day in our departments when it comes to testing a sonic cleaner, I definitely recommend that you go to ST79 as a reference. Hopefully that is a reference that you have and you've heard of and you have in your department available to both leadership and staff, so that you can show them, hey, this is a recommendation here, and it may have some rationale in there for you to explain some of the why behind it as well. So on ANSI AMI ST79, it says to perform cavitation testing daily whenever the equipment is in use. All right. So one of the things that's important to understand about that is in the former version, 2015 version, it was weekly. Now it's daily. Okay. So understand if you're still in that 2015 version, you should be doing this each day that it's in use. Secondly, I want you to understand is there's really it just says to perform cavitation testing. All right. So what does that mean exactly? Well, one way to test for cavitation is to actually use aluminum foil. All right. Aluminum foil should dimple as it is exposed to cavitation. The problem with using aluminum foil, hopefully it's already kind of obvious to you before I even say it, but performing a cavitation test in your ultrasonic cleaner with aluminum foil on a daily basis, with all the variation involved, where are we going to put it in the tank? How are we going to run the cycle? How are we going to determine if it's a pass or fail result? There's some subjectivity to that. That is one of the methods that could be used, but in the real world, it would be very difficult to actually perform that test and then understand and determine the results of it. So then there are tests like these on the right that you can use that just show a change in color and hopefully make testing for cavitation that much simpler. But understand what is out there and available to you in order to perform this kind of test and work accordingly or add accordingly to your procedure. So another thing it says is to request performance verification test methods from your ultrasonic equipment manufacturer. So that's something that they should be instructing you whenever you purchase a new piece of equipment, or maybe you've had your equipment for a long time, you haven't even seen your rep in a long time. It's something that we would definitely recommend that you ask them about. Another one is it says that mechanical cleaning equipment should be tested upon installation, each day it's used, and after major repairs. So it's kind of giving us some guidance there, which will be important when we go to set up our policy and procedure for this. All right. And then another one, it says monitoring critical parameters to evaluate the performance of the mechanical cleaning equipment. And under that, it says key performance outcomes include clean surfaces and adequate fluid flow in equipment that has adapters for lumen devices. All right. And then it says to see Annex D for more clarification on that. You don't have to do that. I put it here. It says to test for cavitation, test for soil removal, and test for soil removal within lumens. And these are just ways that you can do that. So what's important with any presentation is what do we do with this information? All right, we want to get into action steps. So how do we verify that our ultrasonic cleaner is effectively removing soils from lumen instruments? All right, so let's get into that. All right, as you see on the right here, this is actually a paper that we had published just this year, and I'll get into why we published that here in a moment. But as you can see on the left here, I indicate here most facilities are testing their ultrasonic cleaners. All right, and that is a very good thing. However, in our experience and going around and collecting data on these ultrasonic cleaners and what people are doing in practice and in the field there, what we see most of the time is that one of these types of cleaning verification type products are being used. Okay, and understand that all of these products are soil removal tests. Okay, they're not testing for cavitation specifically, and they're not testing for soil removal within lumens. All right, so remember, going back to the three basic functions, and that Amy says to test critical parameters. It also says that fluid flow through the lumen adapters and all of that is another key performance indicator for ultrasonic cleaners. We found out after lots of visits to other facilities and all that they were testing commonly for soil removal, but they were not testing for soil removal within lumens. But many places have ultrasonic cleaners that are equipped with this function, and a lot of them are using it, which is great. But we just recommend that if you're going to use it, you should test it and make sure that it is actually performing properly. So another little tidbit about current state is that we'll go to facilities, and a lot of times their equipment has the capability of doing the lumen cleaning function specifically, so that soil removal within lumens. It has the pump, it has the tubing, it has the adapters. This is an adapter that would hook up via a tubing mechanism, and the adapters would hook up to the instruments. And as you can see there, it's totally empty, nothing is plugged into it. This is actually very common. I just was at facilities recently where the adapter itself was missing. It was broken. Some of them were broken, some of them were missing. So instruments were just being put in there. Whether they were lumened or not, they were not being hooked up to the lumen cleaning function. So that's something that I do see very commonly at facilities. So if you have an ultrasonic cleaner and you haven't been using that lumen cleaning function, maybe just go and see what your equipment is and if it even has that functionality, because if it does, you might be missing out on some automated cleaning function there that would really help you produce cleaner instrumentation at the end of your process. So first, that's what we're going to start with. We're going to assess what is our current testing procedure and whether or not we're actually using that lumen cleaning function. As you can see there with the picture, it's a robotic arm or robotic endo-wrist instrument that is hooked up to the lumen cleaning accessories within the ultrasonic cleaner. All right, so that's just one example. So what is it like in your facility? Do you use it or do you not use it? Secondly, consider adding a performance qualification test for your lumen cleaning function if you are using that, okay? If you're not using that function, I do recommend you use it based on what Dr. Alpha's findings showed in that automated processes, especially with lumen cleaning, are generally just more effective. Third, you're going to use those ST79 guidelines to build your quality assurance procedure for the ultrasonic equipment. All right. So whatever your daily procedure is, use that ST79 as guidance. You don't have to make these things up on your own. You have guidance there, and that's where you would start. And it's going to tell you about when to do it. You know, we talked about it upon installation. We're going to do it every day that the equipment's in use. And we're going to do it after major repairs. All right. And what are we going to test for? We're going to test for cavitation. We're going to test for soil removal and soil removal within lumens. All right. So that's the kind of configuration that ST79 would recommend. And so another thing to consider is ultrasonic cleaners are a huge investment. It's a huge capital investment for your team, and you shouldn't ever take capital investment lightly. So something to think about is when you are in the beginning stages of planning a purchase, work with the OEM and have an understanding in writing that, hey, we're gonna test this thing with these tests, and if it does not pass these tests upon installation, then we should be fully refunded for this equipment because it's not functioning, or it has to be reserviced or what have you. But as a brand new piece of cleaning equipment, it should be able to pass these agreed upon tests. All right, so that's just something to consider to kind of um, you know, cover your big investment, if you will. So I want to get into some case studies because this kind of helps explain the importance of doing all these different tests, and specifically the lumen cleaning one. But as you can see here, this is just one where we did test for cavitation, we tested for soil removal, and we tested all these different hookups. It looks like 12 hookups total for lumen cleaning function. And then on this screen here, you're going to see the results. Okay, all these vials turned color, so it actually passed the test for cavitation. And what did it do? It failed at soil removal, so there's probably an issue there with detergent or time. It could be the length of the cycle was too short, is probably what the real issue is, because we do know that cavitation was taking place throughout the tank. So that is a potential issue that we could quickly resolve just by, hey, add 5 minutes to the cycle time, and perhaps we end up with a better soil removal result. Now, this is an interesting one because all of our tests for the soil removal within lumens, most of them passed. But as you can see, we do have a fail both on the top left here and the top right, which is interesting. All right, so why did that happen? Well, this one on the left, you can't see it, and everything looks great, but I will show you on the next screen what happened with that one. However, this one on the right, maybe you can see it, maybe you can't, but I kind of blew it up over here, but we actually didn't plug it in all the way. So the port was not plugged in, and so the flow was diminished, and therefore it ended up failing. So that is something that we could easily be looking for, especially if we're running these tests every day. You know, it could be human error. We just didn't hook it all the way up the way it was supposed to be hooked up. So that is a potential problem, right? So what happened to that one on the top left? Well, the broken O-ring underneath was the problem. So if you see that, I think maybe just because it's such a small component or small part, people don't generally look for this. I go around to departments all the time and I see broken O-rings on these accessories a lot. All right, they get used a lot and they break down over time. They do need to be replaced, but if you're not convinced that a broken O-ring can really be a problematic issue for your cleaning process, that's what I put this in here for. Okay, so this one over here is a picture on the left of a Sonic that is in operation, and I made it shoot out of the water so you could actually see the stream, and hopefully you can tell, but there is a noticeable difference between the stream on the left here and the stream on the right. And so what I did was I used an accessory over here with a broken O-ring. All right, so that broken O-ring did impact the flow of that water through the channel and through the accessory port. So it is a very reasonable possibility that just a broken O-ring will impact and cause that failure, which is what we saw in that real life case study. All right, so we've seen what a broken O-ring can do to our lumen flushing. What's another potential problem? All right, here you can see that we hooked up just one port for our lumen cleaning function. All right, we have the capability of looks like 6, and we hooked up 1, and you can see the power of the flush coming through really nicely here on the left. But when we hooked up all of them, all 6 ports, the water's barely dribbling through. All right, so the more instruments we hook up in this particular unit, and I would suggest it's probably consistent across all ultrasonic units that have this capability, you're going to lose some water pressure. Hopefully losing water pressure doesn't diminish the cleaning ability of it, but in this case it probably would, because there's barely any water going through. But that's why you test. If you're doing an ultrasonic cleaner that has 32 hookups, hooking up all 32 of them is going to diminish the flow through the system. All right, so that's just something to be aware of when it comes to testing and also real life application. If I know that if I hook up every single port, like in this example right here, if I know that I can hook up all 6, but I get this kind of result, maybe I don't hook up all 6. Maybe I just choose to use it differently. So those are the kind of things that you learn if you do these tests. All right. So here's another case study for you. All right. Hopefully these are interesting to you. I find them interesting. This is what really helps me to learn this kind of material that seems a little bit more complex, but it really drives it home for me. But right here, you can see we have we've passed our test for cavitation. All right, we've passed even our soil removal test, but we did not pass. We failed our soil removal test within lumens. So how can that be? How can it be that we can pass 2 out of the 3 tests like that, right? Well, if you go back to when I broke down all those different functions, remember they all have different components that and factors that are at play that will lead to a pass or fail result of those functions. So what happened in this case? Well, hopefully you can tell on this picture what happened. Maybe it's already kind of jumping out at you, but in case it didn't, what happened here is my friend Sharon Rojo was getting set to retest this ultrasonic cleaner after we discovered the failure, and he was selecting the cycle, and it was about to lower the tray into the ultrasonic, and we noticed that this tubing kinked completely as it was submerged down below the water. So that is what led to the diminished flow through that lumen cleaning functioning portion of the Sonic. So it made complete sense after that why we failed our lumen cleaning test. And we with the customer reached out to their service provider for this equipment, and they were like, oh, that's cool, that's going to be a really easy fix, and they were able to get it fixed and up and running again in short order. So a really good example, I think, of why it's important to do all these different tests, and also why it's really important to kind of do some initial investigation and have some basic understanding of the equipment that you're using every day. Here's another example. So this is a lumen flushing port that is kind of like the other one that I showed you earlier in the first case study, where the tubing just isn't plugged in all the way. It probably is really tight and really hard to push it in, because after time and wear and tear, these things do get really difficult sometimes to push them in and snap them into place. And what happened was, while the thing was running, water is shooting out everywhere, and the water pressure is diminishing inside that lumen cleaning circuit, if you will. So that is another potential problem here. So can the ultrasonic clean lumens if the flushing mechanism isn't used? All right, so I mentioned earlier, a lot of you either don't have ultrasonic cleaners that have the lumen cleaning function, and many of you out there have, uh, whoever made the decision is not using the lumen cleaning function. So there's those two camps out there that maybe they're wondering, after seeing this, well, will an ultrasonic cleaner really get in there and clean inside those lumens if it doesn't have that flushing or cleaning mechanism built in? So a lot of times when we do these tests, we actually load one of our lumen cleaning tests and we don't hook it up to the lumen cleaning function, excuse me, just so that you can see what happens um, inside the lumen when that flushing or cleaning mechanism is not used, that cleaning function is not used. So as you can see in this particular case, it probably got some help from the enzymatic detergent, from soaking and all of that, but we definitely did not come up with an ideal cleaning result. So just something to be aware of in case that was on your mind because of how you use your equipment at your facility. So case study number 3, we have a failed soil removal test for lumen, and this is the ultrasonic that we were using. Just as an FYI, we have this service panel open. Hopefully you're seeing and noticing right away, this is the generator. So the generator likely has nothing to do with the lumen cleaning function, but it is something to be aware of and see that, hey, that's different than the one I showed you earlier. So be aware of that. And then on the side panel, we open up the side panel. This is the front panel. There's a side panel. We find this pump, all right, inside here, okay? This pump is what takes water from the inside of the tank and flushes it through that lumen cleaning circuit, and basically is responsible for that function in the ultrasonic. So it's different than it has nothing to do with the generator or the transducers. This is a whole separate piece of equipment. And one thing I'll draw your attention to is that there is a pressure monitor here, a pressure gauge, and it's actually not at 0. It's actually, it looks like at 10. It's kind of hard to see the numbers, but what's important there is that we do see that there's pressure, meaning the pump seems to be working. All right, so that's kind of interesting. Why did it fail if the pump is working? Well, this part right here, we're going to blow it up for you. This is something at some point I had no idea this was a thing, but inside there is a filter, and that filter was all gunked up. It was really gunked up. So what happened was, I'm not sure if, yeah, we had this filter cleaned out thoroughly, took a few minutes, put it back in, and then that ended up passing the subsequent test. So that was, I guess, if you would, a minor repair or whatever, but we rerun the test and it passed. Okay. So that being said, that's all those case studies. Of course, there's many more from, all the experience we have going around, but I thought those were really good ones to try and really drive the point home why it's important to do this. Understand too, if you're a manager or an aspiring manager, or maybe you're a nurse who runs an ambulatory surgery center, and so you're responsible for sterile processing and the equipment in that department. how do we manage the department if the lumen cleaning function of our ultrasonic cleaner fails and maybe we only have one ultrasonic cleaner? Well, depending on what instruments you're doing, you might choose to shut the entire ultrasonic cleaner down if you're only doing minimally invasive lumen items, things like that. Whereas, in my case, one time it happened at the hospital I worked at, the lumen cleaning function failed, but the cavitation and soil removal test passed. So, and I had a second ultrasonic cleaner. So I was able to divert all the lumen instruments that needed to be hooked up to the lumen cleaning function into the other sonic where it was actually working. And then we could still use the one that was the lumen cleaning function was broke or not functional at the time. We still used it for regular standard instruments that were not lumen. So those kinds of things, being able to run these tests and understand what they're telling you also helps you to properly manage your instrument inventory and where to put things, or how to manage your cleaning process. All right, so all these tests give you information, and it helps you to turn around and use that information for your overall procedure for cleaning and sterilizing instruments. So it's really important. When it comes to dirty instruments in the OR, there are many kinks in the chain that can go wrong, but and you have to look at point of use care. Okay, so nurses and techs, surgical techs, don't be mad at me, but point of use is foundational. But our automated cleaning equipment, if we know that it's way more effective than our manual procedures, we really need to make sure that our automated equipment is functional. So how are we going to do that? Right, we're going to start a process for equipment failure reporting. All right, many places already have this. All right, so say you run a test and it fails, or maybe you run the equipment and an alarm goes off, and then you report that. All right, a lot of times you report it and then everyone just kind of waits for the service tech to come in. Well, I would submit to you that you would be better off if you started doing some things right there in your department to kind of figure it out. All right. Yes, it will take some time, and sometimes there will be times when you literally don't have the time to do this. But many times you do have the time, and many times it's going to save you time in the long run if you do these things. But perform any immediate troubleshooting steps as possible. Check for the broken O-rings, check for proper accessory connections, check for kinks in the tubing, right? Check for the presence of detergent. Check for the proper dose of detergent if you can, if it's possible, right? Check for a problem with the pump or the filter that's associated with it, all right? Sometimes those pump filters that I showed you get so gunked up, and over time they're still trying to use it, that the actual pump goes bad and there's no pressure showing on the pump gauge. So actually there have been times where both the filter and the pump had to be replaced. So if you have in your preventive maintenance plan to have somebody check that filter every so often, hopefully you can avoid a more costly pump exchange. All right. So, and I already mentioned, make judgments on whether that equipment can still be used. And I use real world examples for that. And if necessary, perform a risk assessment with surgery on how to proceed with scheduled cases. I told you there's many places out there that only have one ultrasonic or one washer disinfector or what have you. You got to look at your IFUs. If they don't have built into the IFU a manual process that you can do in lieu of not having automated equipment working and functioning, then you really need to start consider like, how are we going to really process these instruments? Do we have to send them to a neighboring facility within the system? Do we have to shut it down and maybe come up with another idea? Do we have to go as far as rescheduling? These are all things that we should be asking ourselves and discussing with upper level management, including the operating room. Okay, so there has to be some conversation there. We can't just we can't just assume if our equipment goes down that, hey, we'll just do it. We'll do it old school and do it manually and everything will be fine. That's not necessarily the case if the IFU doesn't allow for it. So you have to make sure that that's even a possibility. All right. So, but you can have those discussions because you'll be more equipped with, how your equipment is actually working. So in summary, remember, currently many are testing their sonic for performance each day, but many are not testing the lumen cleaning performance separately, which they should. AAMI guidelines support that testing for three main functions: cavitation, soil removal, and soil removal within lumens. And start testing your sonics for all three functions upon installation, each day it's used, and after major repairs. Excuse me. All right, so at this point, that wraps it up. I do have a little bit of time, it looks like, for questions. I will say, hopefully, if you have questions that aren't addressed, we don't have time to address today, you can email me. That is my contact information. And also the QR code that you see there is where you can fill out a very short survey that will then send you a CE certificate at the end of that to your email address. So I hope you enjoyed the presentation. I hope you learned a little bit about your ultrasonic cleaners and some of the various aspects and functions of them. It's a very valuable piece of equipment as long as it's working properly. And I hope you're a little more confident with it now after this presentation. So Linda, I think we can open it up for questions.
Okay, perfect. Great. Thanks so much, Kevin. Yeah, I've got a few that have come in actually. The first one is, our ultrasonic does not have a lumen cleaning capability. Is there a way to test lumen cleaning without having that set up?
Yeah, unfortunately, if you don't have the capability, you can't really test it. Although, like I showed before in the presentation, we have a lumen cleaning test that we do put in there, and we don't hook it up just so that we can show what is happening inside those lumens if you don't have the lumen cleaning function. So, I mean, technically, I guess you could, but most likely you're not going to have a very effective cleaning mechanism going on inside those lumens because it is a little bit shielded from the cavitation on the inside of those instruments.
Okay, so how do you do lumens in a tabletop ultrasonic that does not have attachments for lumens?
Yeah, so if you don't have attachments, remember one critical step that you have to do, regardless of whether it's tabletop or even a regular standalone ultrasonic that just isn't equipped with lumen cleaning ability or attachments, you do have to flush the instruments, all the lumens, all the channels. You have to flush them in order for any amount of cleaning to happen inside. Now, I will just tell you, based on my experience, that that lumen is probably not getting as clean as it should be. So if you are in that situation where you have a tabletop or a floor ultrasonic model that doesn't have this function, you should be looking at is that function something we could add to it? Remember, I showed you the Sonic earlier where the capability was there, they just weren't using the accessories. Or in your case that you're asking with the tabletop, is there accessories that can be used with it to help flush the ports throughout the Sonic cycle? You might ask that Sonic manufacturer if that's a capability. If not, just put in your your like long-term plan. When we replace this Sonic, we want to get one that has lumen cleaning capability, because over time, many instruments now and many service lines now rely on instruments that contain lumens and should get that lumen cleaning function going. Now, another thing you could do in the short term is there are lumen cleaning pump systems that you could put at your manual cleaning sink and would flush the lumens out before you put them in the Sonic. So that's something entirely different that you could kind of entertain that idea if your ultrasonic does not have that function. I hope that helps.
Perfect. Another question here is, should we be removing instruments out of the DIM baskets and into the ultrasonic washer baskets before putting them in the ultrasonic washer for better cleaning?
So based on what you're saying, I'm guessing that you're wondering if putting your instruments in the Sonic within the regular surgical tray of instruments is better or allowable compared to transferring them into a Sonic container. And I would just say that number one, you have to look at your ultrasonics IFU. So whatever the OEM is and whatever the particular model is, they're going to recommend most likely, at the very least, some sort of basket that has like really wide open mesh or really wide open holes, so that instruments inside can be really exposed to cavitation. Now that being said, some ultrasonics come with their own trays that do provide that, but they may not work they might work really well for minimally invasive because the holes are really big and you can just lay the instruments down in there and they go across. But some instruments might fall through there, and so a lot of times in those cases, if you're doing instruments that would fall through the ultrasonic basket, we would recommend, as long as the IFU doesn't contradict this, to put it in a wide wire mesh basket that allows for the cavitation to really penetrate the instruments. I hope that helps answer your question. I'm trying to kind of imagine in my mind what it was you were explaining, but hopefully that helps.
Perfect. We've got time for one more question. Why do eye instruments require their own separate cleaner?
That's a great question. So I want to say that technically they may not actually require it per like an IFU. It is something to look at in an IFU, but a lot of people have just gravitated towards putting eye instruments in its own ultrasonic because of the problem of TAS. So toxic anterior segment syndrome is a post-op complication from eye surgery that is unique to eye surgery. And a lot of times it was thought to be related to enzymatics and detergents that maybe weren't properly rinsed off. And in this case with a Sonic, especially with eye instruments, you're thinking probably a small Sonic tabletop. It doesn't have the rinsing mechanism, all of that stuff. And a lot of surgery centers that do eyes may not have an automated washer. So if you put it in the Sonic and you don't rinse it adequately after, there is possibility that there's residual detergent or debris on those instruments that could get back to the patient even after the sterilization cycle. So it's not necessarily that they have to have a separate one. It's just a better way to control the process for eye instruments. And that's why I think a lot of people choose to do it that way. And a lot of times those separate ultrasonic cleaners for eye instruments, a lot of times I've noticed people just don't even put detergent in there. They're just doing it with the water in the cavitation instead of doing it with detergent. However, I always would recommend that if you're doing eyes, go back to the IFU, do a deep dive, and go exactly by what it says, because I don't think that necessarily enzymatics are prohibited or that, eye instruments can't share a Sonic with a different type of instrument. I think it's just people have grown to, in their resolve to prevent TAS from happening to their patient population, they've tried to put it down a whole separate aisle of cleaning than other instruments, and that's not necessarily a bad idea. It's just I'm not sure that it's required. You just have to have a really good process in place, and for that, I would recommend going through the IFU with a fine-tooth comb and make sure that you're sticking to the IFU. Because if we're honest, most of us look at sterilization parameters in IFUs, but are we really looking at the cleaning process, the automated cleaning process, the manual, all of that stuff, the inspection? All of those components are usually in there and need to be assessed for our process. So I hope that helps answer your question. That's a really good one. But yeah, most places they just do eyes separately so they can control that whole cleaning process for those instruments and prevent TAS. So I hope that helps.
Perfect. Thank you so much, Kevin. Thanks for your time today and obviously for a very informative presentation. Please visit Healthmark's website, hmark.com, to learn more about the products they provide for the industry. As promised, the answer to today's trivia question is pepperoni. So congratulations to our winner, Christy Edmonds. Just a quick reminder, you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your certificate, and you'll be able to download the certificate directly from your computer once you've submitted the survey. If you have any questions, you can reach us at webinar@mdpublishing.com. Please visit ortodaywebinars.live for more details of all our upcoming webinars and, of course, complimentary registration. Again, thank you all for your time today, and I hope you enjoy the rest of your day.
Thank you.